So in the previous day we have discussed this is the previous day discussion. So in the previous day we have discussed the what are the different type of flow control mechanism. Okay, so there is the different flow control mechanism, that is for the noiseless channel and for the noisy channel. And for the noiseless channel it is the simplest protocol, the stop and wait protocol. In the noisy channel there is stop and wait, ARQ protocol, go back, and ARQ protocol, selective ARQ protocol, like that. These are the protocol. This is the flow control protocols associated with the data link layer. Now in the case of the stop and wait, this is the simplest protocol we have discussed, and this is the different thing we have discussed previous day than the in the receiver side. That means in the error control mechanism we are constant in the sender side and the receiver side both also, but in the case of the flow control mechanism we are associated with the receiver side also, only receiver side. And this is the sender side, receiver side, how the data packet is being sent, acknowledgement is being received, that we have discussed. Now the idea behind the stop and wait, then the simple stop and wait protocol is the very much straightforward. So the simplest stop and wait protocol is, that means after transmitting one frame, that means first the sender is transmitting one frame. So after transmitting one frame, okay, the sender waits for an acknowledgement before transmitting the next frame. The sender, after transmitting one frame, sender waits for an acknowledgement signal before sending another frame. Okay, so this is the idea behind the stop and wait protocol in its simple form. Okay, another frame. So this is the simple idea behind the stop and wait. This is not the stop and wait ARQ, this is simple stop and wait protocol. Okay, so if the acknowledgement, now the problem what happens is that if the acknowledgement does not arrive after a certain period of time, the sender timeouts and retransmit the original frame. Now the stop and wait ARQ protocol is what that, this is the simple stop and wait protocol. Now in the case of the stop and wait protocol there is different problem arises. First problem is that if the data frame is lost, it might happen that the data frame is lost, it might happen that the acknowledgement is lost, it might happen that the acknowledgement is received after a very long amount of time. So these problems are associated with the simple stop and wait protocol. Now in this simple stop and wait ARQ protocol we are just twisting the fact that if the acknowledgement does not arrive after a certain period of time, that means if the acknowledgement does not arrive after a certain period of time, after a certain period of time, then the sender times out. The sender times out and retransmit the frame again. So this is the idea behind the stop and wait ARQ protocol. That means there is a sender and the receiver. Now the sender is sending the frame and waiting for the acknowledgement. Now what happens, the acknowledgement does not arrive after a certain period of time, then the sender, then the process is associated, then the sender, there is a timeout fixed amount of time after which the sender times out and does not wait for the acknowledgement mode and retransmit the frame again. That means it assumes that the acknowledgement signal or maybe the data packet sent by the sender side is lost somewhere in the middle. Both can happen. Then it might assume that the data packet is also lost, or it might happen that the acknowledgement sent by the receiver is also lost in the middle path. So that's why there is a timeout signal associated with the sender side, and after the timeout period it retransmit the original frame again. So that is the idea behind stop and wait ARQ protocol. ARQ means automatic repeat request. This process is actually automatic. So the stop and wait ARQ, stop and wait ARQ. So this is the process we are discussing. So this is nothing but your simple stop and wait that we have discussed in the previous day. The simple stop and wait plus timeout timer. That means there is a timeout signal or the timeout period associated with the sender side plus sequence number. Now the sequence number is the frame number that is associated with the sender side. That means which frame it is sending, that must keep a record. So the stop and wait ARQ is just the summation of these two. That means all of the process is actually superimposed on this stop and wait ARQ protocol. Okay, simple stop and wait, timeout for the timer, that is a timeout signal associated, also the sequence number. Okay, now what happens, there is a different scenario occurs, four kind of scenario occurs in the case of the stop and wait ARQ protocol. The first scenario is that original it may happen that there is a all is okay means there is a sender side, there is receiver side. Now what happens, there is a timeout period. So this is the timeout period from the sender side. Now this is the sender, this is the receiver. Now the sender sends the frame, sender sends the frame to the receiver, this is the frame. Okay, now what happens, there is after receiving the frame, receiver sends the acknowledgement. Now this acknowledgement signal is received within the timeout period. So this is the timeout period. Within the timeout period, the received signal, acknowledgement signal is being received, so there is no problem. So this is the correct scenario. Now what happens, there is another scenario, second scenario. In the second scenario what happens, the original frame is lost. So this is sender side, so this is receiver side, this is sender, this is receiver. Now there is obviously a timeout period from the sender side. Now after sending the frame is lost in the middle. This is the second thing happens. So it waits for an acknowledgement obviously, and after the timeout period what happens, it actually a new timeout period is again started. It actually start the sending the frame again. So it sends the frame again. Don't wait for the acknowledgement for an indefinite amount of time. Now for the second case, we are assuming that the acknowledgement is received properly within the timeout period. Okay, so this is the second case that can happen. Now the third case that can happen, so this is the sender side, this is the receiver side. The sender is sending the frame. Okay, there is obviously a timeout period from the sender side. The sender is sending the frame, so this is your frame. What happens in the third scenario, the acknowledgement is lost in the path. So acknowledgement is lost, so this is your acknowledgement that is lost. So the same process is being followed as in this case. That means sender is not waiting for the indefinite amount of time, rather than it will so as the frame acknowledgement is lost in the middle, it will start again the timer and it will change the frame again. So the same process, and we are assuming that the acknowledgement is received within the stipulated amount of time. Okay. Now in the fourth scenario what happens, then there is sender, there is also receiver. So this is sender, this is receiver. Now the sender is sending the frame, also starting the timeout period. So sender is sending the frame, so this is your frame, sender is sending the frame. Now what happens is that it waits for the acknowledgement. Now what happens, acknowledgement is received here, acknowledgement is delayed, so it will not wait, it will sends the frame again. Now this is the scenario that can happen. So and we are assuming that the acknowledgement is delayed again. So that's why the sequence number is important. So the frame is associated with the sequence number, and it will acknowledgement is also associated with the sequence number. So which frame, which acknowledgement it is receiving, that must be kept a record. If this acknowledgement is not received with that stipulated amount of time after sending the frame, suppose after sending the frame 1 there is a 10-second time period. Okay, so after the sending the frame 1, acknowledgement 1 must be received, within the 10-second amount of time. If it is not received after 10 seconds, suppose acknowledgement 1 is received after 11 second or the 12 second, then this acknowledgement is discarded and it sends the frame again. So, and also this is frame 2, so sequence number is important, acknowledgement 2, so it must be received, so it is starting from 11 and ending at 20, so within that stipulated amount of time the acknowledgement must be received, acknowledgement 2. Otherwise the acknowledgement 2 received after the 20-second time period, that acknowledgement must be discarded because it is not going to be accepted. So that means this scenario is that the timeouts fires too soon, that the timeout period is must faster. So that is the process by which stop and wait, automatic repeat requests, all this process will be automatic. Hope you understand the working of the stop and wait ARQ protocol. All these 3-4 scenario that I have discussed, this is not manual, this is automatically programmed into the system. Okay, so that is being implemented. Okay, so the last discussion, that the concept, that the last problem, that the sender is sending this frame and receiver is there is acknowledgement is received after some amount of time. That means sequence number is important to resolve this problem. So this problem is actually discussed into our next protocol, that is called the sliding window protocol. Okay, so this sliding window protocol, sliding window protocol. So this is the sliding window protocol. So upon completion of this session, the learner will be able to understand the drawbacks of the stop and wait ARQ protocol, know the need for sliding window protocol, and understand the working of the sliding window protocol. In the case of the stop and wait ARQ protocol, the idea is that we are not discussing again the stop and wait ARQ protocol. It is protocol is simple, that means after transmitting one frame, sender waits for an acknowledgement before transmitting the next frame, and if not acknowledgement is received, there is a timeout for the sender side and it actually times out. Okay, now this is the stop and wait ARQ protocol that we have discussed. Now what are the drawbacks of the stop and wait protocols? Stop and wait ARQ protocols drawbacks is, that is the drawbacks. Okay, that's why we are introducing the sliding window protocols. So drawback of stop wait ARQ. Okay, so drawbacks of stop and wait ARQ, that means the one frame at a time. So we are sending one frame at a time. That means all whenever we have discussed the stop and wait ARQ protocols, that you have seen from the diagram, the sender is sending only one frame at a time, only one frame at a time. So that is the drawback. So why this is drawback? Because if the bandwidth of this channel is very large, that means the poor utilization of bandwidth. Okay, so if the bandwidth, we are not properly utilizing the bandwidth, because the bandwidth is very large and we are only sending a very small amount of data. That means one frame at a time, that means we are sending a very small amount of data. That's why we are not properly utilizing the whole bandwidth. So that is the problem associated with the stop and wait ARQ. Okay, so that's why we are goes into the sliding window protocol. Now what happens into the sliding window protocol? Sliding window protocol, it sends, first is eliminate the first drawback, that means stop and wait ARQ protocol sending one frame at a time. Now it must sends multiple frames at a time, otherwise it is not used to the higher version. So the multiple frames at a time, it sends multiple frames at a time, so that it can properly utilizing the bandwidth of the channel. Okay, so next, number of frames to be sent is based on the window size. So number of frames, so there is a concept window size. So number of frames to be sent, how many frames to be sent at a time? Okay, to be sent is based on window size. So this is the new concept, that is the window size. What is window size? We will learn in a few minutes. Okay, so next is each frame is numbers. So that we have discussed in the last problem. That means the last problem in the stop and wait ARQ, or the last scenario of the stop and wait ARQ, each frame is numbered. That means the sequence numbers. Each frame is numbered. Sequence number. Sequence number. Okay, this is also a new concept. Okay, so two new concepts have been introduced. First one is your window size and second one is your sequence number. Now let's see how it works actually. So this is not a very difficult. It is that means the working. So the main advantage of using the sliding window protocol, that means it can use the multiple frames that I have write down here. That means the number of frames to be sent is based upon the window size, and it sends the multiple frames. How many frames to be sent, that based upon the window size of the system. Each system window size is different to the other system, and also each frame is numbered. That means there is a sequence number for the each frame. So now the working, in the case of the working, suppose there is 10 frames. 1 2 3 4 5 6 7 8. So I am just numbering the frame, each frame 1 2 3 4 5 6 7 8 9 10. So suppose how this number is frame is actually associated. So this is the frame. Okay, frame number 1, frame number 2, like that. So suppose there is a sender and there is a receiver, like this. So this is your sender and this is your receiver. So it can send the multiple size. So here I am assuming that the window size is 4. Window size is 4. So as the window size is 4, it can send the 4 frames at a time. So the window size is 4 means, so 1 2 3 4. So it will first select this 4 frames. Okay, and it will send one by one. That means it will send frame number like this. So this is frame number 0. Okay, sender frame number 0, frame number 1, frame number 2, frame number 3, like this. So I'm not writing here 0 like this. So it can be 1. Okay, 1 2 3 4. Okay, so this is 2, this is 3, this is 4. Okay, and after sending all this is the window size is being selected. This is the window is being selected. Window size is 4, that's why 4 frame is being selected. So after sending all the frame, suppose acknowledgement for this 1 is being received. So after the acknowledgement for this frame number 1 has been received by the sender, so what happens, this total window size is being, so after receiving the acknowledgement 1, then the window is being shifted like this. So this is your window, so window is being shifted here, sorry. So this is the from 5 to 2. Okay, so now this is the window because this data packet from say this frame 1 has been sent, and the acknowledgement from this data package is also being received. Okay, so that's why we are just moving this window, slide this window to the left hand side and sending the data packet 5 from the sender side, and this process is being continued. So again after receiving the acknowledgement for the data frame 2, we are again moving this we are moving this data window to here 6 3 4 5 6. So how this actually works? Okay, one by one. So this is the your concept of sliding window protocol. Now in the case of the sliding window protocol, suppose this is the frame. So this frame 1 and 2, suppose this frame 1 and 2, this is called 1 and 2. Okay, 1 and 2, and these are the frame divided into 3 category. So these are the frames, and this is the current window, and these are the frames. Okay, so this is called not yet sent frame, not yet sent. These are the not yet sent. This is sent but not acknowledged, sent but not acknowledged, and these are the frames that is being sent and acknowledged, both. Okay, so this is how it is being divided. So hope you understand the drawbacks on the stop and wait ARQ protocol, know the need of sliding window protocol, and understand the working of the sliding window protocol. Thank you.